Welcome all of you. Welcome to this course on Docker and Kubernetes. I welcome all of you to the world of containers. The course name is Docker and Kubernetes. Can any one of you please confirm whether I am audible and my screen is visible? Keshav, Nagalakshmi, Pandu, Ratvik, Sandit. Yeah, okay, thank you. Docker and Kubernetes. The beauty of this Docker and Kubernetes is very much relevant in the world of containers. My statement was wrong, or some grammatical it was wrong. I was thinking about something which is there beside my laptop. That's fine. Okay. So what are containers? When we talk about Docker and Kubernetes, we always talk about containers. What are containers? Before going to the discussion of Docker, Kubernetes, and containers, let me go to the philosophy of Plato. Very famous philosopher Plato, in his book Republic, Plato said that necessity is the mother of invention. Necessity is the mother of invention. That means whatever mankind has invented, right from the birth of man till date, man invented them because of their need. That means agriculture was invented. Why? Because there is increasing demand for food. So man invented agriculture. Computer was invented. Why? Because there is need for high computation. Like that, different trade routes were invented because of need for trading of the goods. Like that, the concept of containers was also invented because the software industry was facing some issues during those times when the concept of containers was not there. What was the problem? Let's go back to the history, how the IT infrastructure was there. There, if you know this already, software development life cycle, SDLC, software development life cycle starts with development of source code. Who will develop the source code? A team of people called developers will be there. They will develop the source code. Okay. If the application is Python based and if it is Flask based, then the Python engineers will be there. If it is Java application, Java developers will be there. Like that, if it's a Go application, Golang developers will be there. Like that, different kinds of development people will be there. Once they develop the source code, this is little bigger, they will develop the source code. They will develop the source code. Okay, let's say print hello world. Print hello. This is the application, let's say. Let's say this is Java application. Who will develop this source code? A team of people called developers. Then in DevOps culture, where this source code will be stored, it will be stored in some central server called as repository. Let's say this is GitHub. Okay, so we have Bitbucket, we have GitHub, we have Azure repos. Anyway, so behind the architecture, Git will be working. So this source code will be pushed to the GitHub. Okay, that is fine. And when the source code is pushed here, Other team members will be able to work on different feature, and later it will be deployed into the QA environment. It will be deployed into the QA environment. Okay, same application. And after that, if the testers have been passed, then it will be deployed into the staging or UAT environment. Then after that, it will be deployed into the production environment. Okay, that is fine. This is the case. Now, let's say our developer is having Windows machine. This is hardware. This is of capacity. Let's say memory of 16 GB, CPU, let's say 8 cores. Okay, then developer will be having Windows in this. Developers will be having Windows as the host operating system. Windows operating system. Now the requirement for that developer is to have Ubuntu machine. The requirement for the developer is to have Ubuntu machine, because the application that he wants to develop can be done only in the Ubuntu environment, in the Linux environment. For that, what we have to do? We have to provide, the organization has to provide another machine in which Ubuntu is installed. That is one thing. In that case, what happens? This hardware is having some additional resources which are not being used. Okay, here Windows is running and he wants to have Linux machine. For that, what we are doing? We are giving him a new hardware and we are installing Ubuntu machine. This is waste of resources. To overcome this problem and to have the Windows, to have the Linux environment, Linux operating system in the same machine, a new tool came that is called as what? Hypervisor. So in the same machine, in the same hardware, we will install hypervisor. Okay, so our base operating system is Windows operating system. This is also called as the host operating system. Now the requirement is that we have to give developer a Linux bus, a Ubuntu operating system. For that, in order to have the Ubuntu operating system in the same hardware, we have to use a tool called hypervisor. Using this, what we can do is we can spin up a Ubuntu machine in the same hardware. Okay, we can spin up another Ubuntu machine as well. It can be Red Hat, this can be Debian Ubuntu, like that we can do. Here, what is happening? We are optimizing the resource utilization. Earlier, before this hypervisor technology has come, we have to get the new hardware. In that, we have to install full-fledged operating system, that is Ubuntu. But with the help of hypervisor, I'm able to optimize the resource utilization, which is sitting idle in this host machine. Now I'm able to spin up the Ubuntu operating system in the same hardware. Okay, some development has been taken place from earlier to this. Okay, that's fine. We have given this Ubuntu machine to whom? The developer is having this Ubuntu machine in the same hardware where his Windows is running. Fine. Once he gets this Ubuntu machine, he will now start installing the dependencies for the application. Let's say, for example, he is developing some Java application. For that, he has to install one Java in that. Then only he can develop the Java application and he can test it locally. And after that, he will be developing the application. Let's say the application name is application 1. And here he can install another Linux machine, that is CentOS or Red Hat Linux. So after that, you can install, you can develop and run the another application. Let's say application 2. Okay, forget about that. Now let's say this is also Ubuntu as of now, and he has to install the required dependencies. Let's say Java here as well, and let's say this is Java 8, Java 8, and here the requirement is Java 11. Okay, let's say that is. Now once this is done, let's say the developer, let's say single developer is there in the team. Okay, let's make this concepts very simple. Once this is developed, okay, and tested locally, then the developer will finally push that to the central repository, that is GitHub. Okay, this is GitHub. Now what he will push to GitHub? Only this part, only this part will be pushed to the central server called repo, that is GitHub. Okay, and just I want to name this as dependencies. Okay, the application may require multiple things, right? Okay, so now let's say dependencies 1. Okay, so the Java application may be required another benefits and libraries also. Together I am calling them as dependencies dep 1. So in this case, the application has been developed and the application source code is now pushed to the GitHub. Okay, now it is stored here. Now why it is pushed to here? The developer is now confirmed that the application is developed, so he can finally say to the operations team to deploy the same in the QA environment. Okay, so now let's say this is the QA environment. QA environment means, let's say this is some machines will be running here, right? So this application will be deployed here in this QA environment. Okay, remember, to run this application we need to install these dependencies here as well. Now the problem is this application may have 4 to 5 dependencies. That you keep remember that. Why? You have different versions of Java, we have different versions of Python. Like that, all these different may be having different versions for the same dependency. That is one thing. Okay, but application source code is same. Now if I come to QA environment, here the environment is Ubuntu, but here the environment may be CentOS. Okay, if this application is deployed here, the application is failing here. Why it is failing? The reasons are the operating system in which this application is developed and tested locally. This is the operating system, and the operating system which is installed here may be different. Here it may be Red Hat, this is Ubuntu. Okay, some way we recognize that we may feel that this is because the operating system is different, the application is failed to run here. So what we do is we will replace the operating system. Now I will install Ubuntu here as well. Okay, and in that case, this may be here Ubuntu 18. We may be installing new version of Ubuntu here, let's say 22. That may be the reason for the application to be failed in that. That is fine. We some way managed to get the same operating system here as well, that is Ubuntu 18. That is same like that of the dev machine. Fine. So at one level, very hardly we are able to bring up the same operating system in the QA environment. Okay, but the scene is not over. Even if I install the same operating system in QA as well, still there is a possibility for the application 1 to be failed in the QA. Remember, This is successfully running in the dev machine, but coming to QA, it is failed. First, we thought that it is because the operating system is different from here to here. And some way we managed to get the same operating system in the QA environment as well. But why it is failing again? Because the dependencies, we may be having 4 to 5 dependencies. Let's say here it may be Java 8, we may be installing here Java 11. In that case also, so if we have 5 dependencies, one dependency we manage to install the same, that is Java 8 here. What about other dependencies? We can't guarantee that same kind of environment will be there in the QA environment. Okay, so now QA people will tell that this application is not running successfully here, but developer people will tell that he will show in his machine that the application is successfully running and his task is over. That's why he has pushed the code to the GitHub. So this kind of firefight between developers and QA people is happening. What is this fight? Developer will show that the application is successfully running in his machine. QA people will tell that this is not running. The same application has been deployed here, but it is not running. This is a fight between them. Okay, so that is the situation. Now, imagine a situation where we can copy the application along with its dependencies. We can copy the application along with its dependencies and store it in some central server. Okay, store it in some central server and deploy that into the QA environment. Okay, QA environment. Here the problem will be solved. How? Because this is very easy. We can have the same kind of Ubuntu. Okay, even if you don't have the same operating system as that of here, that is fine. We will come to that concept later. Okay, so there is no need to be having the same operating system here and here. I will tell you that later. We will understand slowly. So here the problem with the dependencies now overcome. Why? Earlier only we are shipping we are transferring the source code, but in this case, along with the source code or along with the application, we are also shipping or transferring the dependencies required for this application from one environment to the other. If this application is successfully running, it will also be successfully running in the QA environment because we have copied the same environment here as well. That is fine. If this is running successfully here, it will also run successfully here. And if it is running successfully here in QA environment, and if it is tested against various test cases like regression test, performance test, unit test, sanity test, if everything is over, then this can be deployed into the production environment. The same thing can be deployed into the production environment happily. This concept is called as containerization. This concept is called as what? Containerization. In containerization, what we do is we will pack the application along with its dependencies and we will ship that package, we will ship that container, we will ship that image. We have to understand what is image and container. That is what this course is all about. You will understand that in 1 or 2 classes. Okay, So here, this is what containerization means. Okay, now let's go back to the shipping industry and see the beauty of it. Okay.
Sir, here one query, sir. Hello.
Yeah.
Sir, this container will be placed on top of hypervisor or it is separate?
You will understand next in next 2 or 3 diagrams, so you will understand that. Okay, so please be patient. And I'm seeing some questions in chat. Actually is saying screen is not visible. It's not screen is visible, I hope. Okay, so Vivek has answered that. What is the class timings? Okay, I will tell you, it is from 8 to 9 only, friends. 8 to 9. Okay, sharp at 9 we will close this. This is the thing. Okay, so you please understand this. In the case of non-container world, before the container technology is there, this was the situation. Only application can be transferred from one environment to another. We have to bring up the environment afresh in every environment. But in case of containers, along with the application, we are also shipping the environment, that is dependencies. Okay, this is now. If I come to containers, before going to the technicals of container, I want to go back to shipping industry. So let's say a person is owning a ship. Okay, ship, you know. Okay, so ship will, what it does, it will transport the goods from one location of the world to the other location over seas and oceans. Okay, and we have inland shipping also, like in rivers also. In some places the government has come up with the shipping through waters. I think that can be seen in Assam and other regions, West Bengal region, okay, where the water facility is available. That's fine. Okay, this is ship. A person is owning a ship of capacity 10 tons. Okay, in real time, the ship capacity will be 100 tons. Okay, so earlier, before the containers, let's say this is ship owner, is having this much of capacity of ship. Then let's say customer came to him and say that he wants to transport 3 tons of fish and 2 tons of raw material from one location of the world to the other location. Let's say from Maldives to Sri Lanka. Okay, this is now what the customer is saying. He wants to transport 3 tons of fish and 2 tons of material. What shipping industry used to do here is the 3 tons of fish will be put like this. Let's say this is fish. Okay, then and raw material. Let's not use this for fish. Just want to be crazy. Let's use this for fish. He wants to transport 3 tons of fish. Okay, so fish will be having different sizes. 3 tons of fish and 2 tons of raw material. 2 tons of raw material. Okay, so now what this ship owner will do is he will put the fish and the raw material like this. Okay, let's say he will be separating them with some distance. And if you know, commonly what we know is that fish needs one kind of environment, raw material needs another kind of environment. Now let's say raw material here is the feed for the fish or something else. Let's say some iron, some food material, whatever it is. And fish needs cold storage, cold environment. Fish needs what? Cold environment. Okay, fish will be put in the ice and this will be separated here. If this is the situation during transit over the sea, there is always a possibility of this fish and raw material mixing together. Even though we have separated this, and this is not the only two material, this is only the customer's one material, and a customer two may be coming, and he also wants to transport his goods from Maldives to Sri Lanka. So that kind of material will also be put somewhere here. Okay. So during this transit, there is always a possibility of mixing up this fish and the raw material. If this fish and raw material is mixed together, then these two materials will be spoiled. Now the shipping industry came up with the concept of containers to overcome this problem. Now in container, what they do is they will create empty boxes. They will create empty boxes of equal size in general. Okay. And let's say each container is having of capacity 1 ton. Okay. So now 1 ton. Now 3 tons of fish will be put here. Let's say this is 1 ton of fish, and another ton of fish will be put here, and another ton of fish will be put here in this container. And raw material 1 ton or 1 ton of raw material will be put here, and the ton of raw material will be put here. Okay. Now they are put inside the boxes, and this box contains cold storage. Cold storage in the sense is some ice. This is ice. And this is dry storage. We don't need to specifically create for that. There are some iron boxes also, or some plastic boxes. Okay. So now what they have done is they have created these empty boxes called the containers, and they have put the material like this, and they are now putting them like this. Now what I will do is I will just minimize this. Okay, no worries, let me delete this. So they will be putting this one here. Like this. See, now this is very perfect setup where fish is having its own environment and raw material is having its own environment. There is no possibility of mixing of this fish and raw material during transit. So from earlier to here, how much development has taken place in the transportation over the seas? So in today's world also, everywhere containers are there. I will show you. So now this is the setup. They are isolated in some aspects, and they are using the common resource, that is shape. They are isolated in some aspect where they should be isolated, and in some aspect they are sharing the same environment, same resources, that is ship body. This is the concept of containers. Now you can imagine this fish as Java application which requires Java 8. You may think this raw material as another Java application with Java 11 dependency. This Java is installed, Java 8 is also installed in the system, Java 11 is also installed in the system, and we are running the Java 8 application, we are running the Java 11 application, and they are isolated in that aspect, and they will share the same system, memory, CPU, and disk space. Concept of containers. Okay, so containers are nothing but empty boxes to put some material into that, so that some kind of isolation will be there with that of other applications or other containers. This is now the same thing will be applied The same analogy has been taken to the software industry to come up with the concept of Docker. Who created Docker? Docker is created by Salman Hayek. Okay, so in 2013, if I'm not wrong. So this is. Now, let me go back to the real world containers. Not shopping, should be images. See, these are the containers. These are the containers. See, this large ship is having the containers placed in this. Okay, this is the container macro level. Okay, so if you observe, recently I read in the newspaper that Rahul Gandhi, yeah, we all know that across the nation, Rahul Gandhi is now started Bharat Jodo Yatra, right? So in that, Bharat Jodo Yatra containers. See, Rahul Gandhi is using containers, not Rahul Gandhi. Let's say that for his this one, Bharat Jodo Yatra, these are the containers. They are isolated boxes. They will be having beds and all. Different containers will be there. One container is for Rahul Gandhi, another container for local leaders, another container for state level leaders, and some containers will be used for meetings, and some containers will be used for toilets, some containers will be used for what? Food and those kind of things. The container technology is being utilized everywhere, even in the road transport as well. Containers in road transport. See, these are big containers. Okay, in airways also. Containers will be used. Okay, things will be put inside the container and they will be shipped from one location of the world to another location over the air. Okay, this is the concept of containers. Now let me go to the technicals into that. So now what I will do is, so earlier setup was, this is hardware. We have some resources here. For this hardware, definitely resources will be there. Let's say memory of 16 GB, CPU of let's say 8 core or whatever it may be. Okay, let's not focus on the numbers. This is, and we have host operating system. It can be Windows, it can be Ubuntu or anything. This is called as host operating system. Then on top of that, we are installing hypervisor. And in order to have Ubuntu operating system, this hypervisor will enable us to create a guest operating system, that is Ubuntu here. Okay, this is called as guest OS. Okay, and application one will be developed here. For that, we need dependencies. Let's say libraries. Let's call them libraries. So now in this case, what is happening? We are able to only transport the source code. But, and one more thing is that this application is running. Let's say this is a deployment, a server. Okay, let's say production server. And this application is running on this Ubuntu one machine. And in case of hypervisor, if we want to have this guest operating system, that is Ubuntu here, we have to install full-fledged operating system that is as heavy as if we are installing the full-fledged operating system in a brand new hardware. Okay, the same kind of operating system we have to install here. Okay, we have to download the Ubuntu OS IO file. Then we have to install that using the hypervisor. So let's say this is application 2. Here also it requires libraries. Okay, if it's want to run here, then again we are creating one more guest operating system. In this case, our main motto is to run this application 1 and application 2. In order to do that, what we are doing, this is mandatory. We are installing some tool called hypervisor. To install this, it will consume some system resources. And when we are installing this highly weight operating system, this will also consume resources. This will also consume resources. And finally, how much resources will be available for the actual application? Only less, only peanuts amount of resources will be available for the actual application to be run. Okay, so but if I come to the containers, okay, so we will be running the same. In case of containers, in place of hypervisor, we can use hypervisor and we can install Docker in that. That is different story. We use container runtime. Let's say Docker in our case. Okay. Now this is fine. Here also it requires some resources to be installed. To install this, here also this will consume resources to install this Docker here. That is fine. But if I want to spin up the Ubuntu environment, I can do this, but okay, I can do this here. I can run the application 1. Here, these are libraries. Okay, here we have eliminated the need for installing full-fledged operating system. And here, this container or this virtual machine will use the underlying operating system kernel. Let's say this is Linux kernel, Linux containers. So this is a Linux machine. Let's say it will use the Linux kernel. But here we are installing full-fledged operating system, which will also consist of the kernel, and that is very high weight. But here we are running this application and we are also running another application, and both are isolated perfectly and they are running in different VMs. Okay, so but here we are not installing the full-fledged operating system. Instead, these containers will be using underlying operating system kernel. And today, till today, we have only Linux containers. We don't have Ubuntu Windows containers. Okay, so if this is Ubuntu operating system, we will be having kernel in that. The same kernel will be utilized by these virtual machines called containers. From here to here, the difference is here we have to install full-fledged operating system. Here, these containers can be spinned up within seconds. Within 5 to 6 seconds only, we can install this VM. But here, it will take 30 to 40 minutes to install the operating system and to run the application. But within no time, we can spin up this virtual machines. We will see that practically. And you may be getting a doubt. Now, okay, that is fine. Now, what we can do is this entire container here, only this can be shipped, but here in this, we can ship the entire container, okay, from one part of the, from one environment to the other environment through the repositories. Okay, this is, and we can spin up as many containers as we want, as long as system resources are available. Okay, now one thing is containers can be applications can be run in the containers, which can be run in the Ubuntu in this underlying OS. That means, let's say we can containerize the application. Let's say we have a full-fledged Ubuntu operating system. We are able to develop and run the application X. Let's say application X. We can run this application X in the container as well, because we are able to run that in Ubuntu. This is one thing. Let's say we have some application Y and this is failed to run. This is failed to run here. This is failed to run in this Ubuntu. This application Y also, Y can't be run in the container as well. Okay, so if we can run some application in the Linux machine, then only we can containerize that application. If we are not able to run that in Ubuntu in Linux machine, we can't containerize that. This is very important point. And another thing is that I said we have only Linux based containers, and these containers will be using underlying kernel, operating system kernel. But what if this host operating system is Windows? Okay, these containers can't use that Windows operating system kernel. Okay, in that case, what we have to do is, if you want to install Docker in your Windows machine, along with the Docker, we also need to install Windows subsystem for Linux. Okay, this is Linux kernel that can be installed in the Windows operating system. So these containers will be utilizing that. So from here to here, the thing is, here we are, in case of hypervisor, we are installing full-fledged operating system, but here we are not installing, we are just having the containers, and these containers will be using underlying operating system. Okay, that is, and these containers, and here what we need to do, we have to dedicate the system resources upfront. When we are spinning up this Ubuntu machine, we have to allocate some amount of CPU and memory in advance, let's say 4 GB and 2 CPU. Upfront, whether this application may be using this or not, we have to dedicate this upfront. Okay, but in case of containers, we don't need to do that. Containers will be utilizing the resources as much as they want, and we can restrict them. Okay, that is different story, we will learn that. Okay, we are not dedicating the resources upfront. Okay, here resource optimization we are doing. This is till now. If any one of you having any doubts, you can ask me, and the people who are sleeping, you can wake up.
So I just want to know here, in the first image, on top of hypervisor, we are having multiple guest OS, right? In
Yes.
each guest OS, we are having a application 1, and other guest OS we are having application 2. Can we have a multiple application on single guest OS?
Yes, we can have that, right?
So like, what is the necessity of having multiple guest OS then in first diagram?
Okay, so for example, let's say it
Because
requires,
we can also have a container, right, on top of hypervisor.
yes, here also we can install Docker, and from here also we can spin up the containers. I'm just taking, for example, there is a possibility of having multiple, let's say if you want to Ubuntu here, that we can have. If you want to Red Hat, we can have it here.
Okay.
You have to install full-fledged Red Hat here. That's what I'm trying to tell.
Okay, so image 2 will become a lightweight, right, compared to that.
Which image? This one?
Yeah.
Yes, they are very lightweight. So, for example, let's say if you want to install Ubuntu here in this, what we have to do? We have to download the ISO file, right? Install Ubuntu. Okay, now Ubuntu 18, let's say 18.04. That file will be there somewhere. That ISO file will be there, right? We have to download that first. Just where it will be there. That will be about 4 to 6 GB size will be there. Where it is, that should be there. Then yeah, somewhere they are giving like download. Okay, get Ubuntu. Let's see if we click on see this ISO file will be. It is about 4 GB of size. But in case of containers, we can have just 100 MB. Even we have the containers which are having 2 MB size also. That much lightweight, we can spin up in no time. That is, we will observe that. Okay. And you can install this Docker in Windows. You can install that Ubuntu or anywhere. And as a part of this course, what I will do is I will share my entire notes for both Docker, and this is containing about 70 pages. And for Kubernetes also, I have a notes of about 100 plus pages. This entire notes I will share you. The same notes I will be sharing with you all. This is, it will be loaded. So then, yeah, let me brief about the course.
Sir, sorry, are you there?
What you are telling? I am there.
Okay, actually, I just joined the meeting and sorry for late. I just read the message right now. And can you, do you, I mean, will you repeat the same topic tomorrow? Or?
You can happily go to the video, you will understand clearly. Okay, they will be sharing this link with you through mail. They will follow for fee payment and all. So they will definitely share this demo link with you. Don't worry, you will understand clearly this.
Okay, and sir, one thing
And
more.
if you have any doubts, you can ask me in the next class. That's fine.
Okay, and in the demo class, you will go ahead with the next topic tomorrow?
Yes, next topic. Next topic. It will be continuation of the course only. After 2 or 3 classes, the link will be disabled and people will be allowed who have paid. Okay. Okay. Demo something like people will think like demo something like I will give. No, this is the first class. You can think this as a regular class, but after 2 or 3 classes, only people who paid money they will be allowing that. That means people will be allowing.
And when I will pay the money, then you will start from the scratch, or then you will continue where you left in the demo class?
I will continue. Okay, no need to be starting from some scratch. You can go through this video.
Okay, and sir, I have like 2-3 more silly questions. How many days this course is?
Yeah, that's what I'm trying to describe now. I'll tell you.
Like how many days it will take to cover?
Docker and Kubernetes is the course name. Duration is 45 days. And some people will tell that why 45 days? So it can be done in 1 or 2 weeks. That's not, we have to learn everything, right? So Docker and Kubernetes class timings will be 8 p.m. to 9 p.m. Indian Standard Time it is. Weekdays, it will be on weekdays from Monday to Saturday, Monday to Saturday. And what you will get is, you will get live classes plus recordings through Google Drive and plus notes as well. Complete notes I will be giving, and the fee is 4,000 INR. And how to pay, whom to follow, all these things, I think admin people already pinged in the chat box. You can ping them and you can contact them. This is the description.
Okay.
Sir, one query. So those notes will have only theory part, or it will have all the configuration like installation?
No, nothing. Everything will be there. Okay, commands, definition files, everything will be there.
Okay,
Okay,
sir,
Sir,
got it.
what is the prerequisite of this course?
what?
What is the prerequisite of this course?
Yeah, that is good question. Prerequisite for this
Thank you.
course is nothing. It is good to have some Linux knowledge, but that's also fine. You no need to have any knowledge on that anyway. Okay, but what is apt get command, apt install, mkdir? These things you should know. They are very ABCDs in the Linux, right? But that will also you will get to know in this course during the course.
Okay, okay. And
For
sir,
Kubernetes, Docker is the prerequisite. For Docker, there is no prerequisite.
I'm sorry, what?
What?
What you said in Kubernetes, what you said?
For Kubernetes, Docker is the prerequisite. Without Docker, you can't learn Kubernetes. But to learn Docker, there is no prerequisite required.
Okay. And sir, the last silly question is where we use these Docker and Kubernetes. Actually, I don't have any idea about this, but
Okay, I will tell you. Developers. Okay, before developers, today we are in the DevOps culture, right? We will be
yeah.
deploying the applications in cloud. To get high availability, we will be using the Kubernetes in deployment of the microservices in the form of containers. Okay,
Okay.
so that is in cloud, we will be having Kubernetes clusters. In that cluster, this will be deployed. And to be frank, this is for DevOps mostly. Kubernetes is DevOps for, but today the Docker is required for developers mostly. DevOps anyway, they require Docker because they require Kubernetes, right? Developers are required to write the Docker files and to Dockerize various kinds of applications. Okay, so today if you go to some Java profiler anyway, they will mention Jenkins also, they will mention. You will be searching for what is it? Go to Naukri, and there
Yes,
if you search for
you know,
yeah,
I know Jenkins and these keywords which is highly demanded
yeah,
in the
yeah.
market.
So if I go for Java jobs also, they will be asking some DevOps tools. They will be asking Jenkins. They will be asking for this Docker, such kind of things also they will be asking. Okay, so microservices means you will come across containers there. For that, you need to have the knowledge of Docker and all. So here Unix, they are asking mm, like that Git tools and everything. Okay, I have seen in many profiles they will be asking Jenkins. Even I have my friends who are see here in this cloud is asking. They are asking cloud means they will be asking some cloud services like container registries and Kubernetes and all. Okay.
Sir, if like I am like the I know about the AWS. I don't
Okay.
know anything about the Java. So is there any combination with the AWS and the Docker and Kubernetes?
Yeah, definitely. Because I will spin up this Kubernetes cluster in AWS.
Oh, okay. So
And I
you
will
will.
install this Docker in EC2 instance of the AWS because I want to give you the real-time exposure. If I install my Docker in my Windows laptop, that is not good. If I install Minikube in my Windows laptop, that is not good because that we want to use in the real time. Whatever
Okay.
the real time, we will be using commands. And some people have said this is only theory or real time. Everything will be real time. Everything we will work on a command line. Okay.
Sir,
Okay.
this file be like downloadable or what?
This
This
file,
note
I
file.
this admin, this institute people will be sharing this through you drive. I will upload to the drive that they provide to me. And you
So
will,
can we like do we whether we'll have access for copy like or it will
you
be
can,
just
yeah,
read
you are
only?
telling that yes, you can download this. You can
Okay,
download
okay.
this and uh, you can
Yeah.
do anything with it.
Okay. Because video will be not downloadable, right?
I think video won't be downloadable.
Right. And second question, sir, will it be any project associated with it? Kubernetes?
Yes, sure, we will see. And one thing, right from the first class to the last class, everything we do that will be doing in the project only.
Okay. Okay.
And sir, how to put it in the resume? Will you guide us that also?
No, because this is not a full-fledged DevOps course, right? Generally, DevOps, what they will do is, so generally, DevOps will be having about 10 to 15 tools. You won't be learning this Docker and Kubernetes intensively there. Okay, so I want to make this some specialized course so that people will be learning, and I will also get some advantage over this. Okay, so that is why. So if you have the old DevOps profile, you can put this Docker and Kubernetes, and you can crack the interviews. I have created that. I have created the Docker file. I'm responsible for deploying applications into the Kubernetes cluster. I have auto scaling. I have agile pod auto scaling. Like that, you can say whatever the things that we are doing. You can tell that. You have to include this Docker and Kubernetes in the resume if you are from DevOps, because this is the heart of DevOps. This Kubernetes is the heart of DevOps.
Heart.
Heart means HEART.
Dil.
Yes.
Okay.
Okay.
And sir, will you teach Jenkins also?
No. As of now, I am restricted myself to Docker and Kubernetes only.
Okay. Sir, I'll be able to follow up without having knowledge on AWS or Azure?
No need to have any knowledge on that. With that, just we will install Kubernetes in AWS, but everything, whether it's a Kubernetes installed in Azure, GCP, or AWS, or in our on-prem, everything will be same. Okay, let's say if
you'll be going at a slow pace when you are installing in AWS, because
sure. I have documented the steps. I will teach you how to install that in AWS.
Okay. Sir, will you be covering any monitoring related to Kubernetes specific?
Yeah. In Kubernetes, we will use Prometheus and Grafana. I will show you the deployment of that.
Yeah. Thank you.
Okay.
Okay, sir. And you are going to send these through the email, or how we will get the documents?
These documents, they will be sharing us with you and with me. They will share us some drive. I can just directly give this through the chat box also. No worries. I can give whatever the means you want. It is downloadable. I can share.
Okay.
So even if they don't allow you to download, I don't know whether they will allow you to download it. I don't have any problem. I can directly send that to in the chat as well. Okay.
And sir, can you please share your phone number also if we will have any doubt? Then
No. That according to the institute rules, I can't do that. But once you pay the fee, I will ask them to create the Telegram group. In that, we will give the updates about the class. And if you have any queries, you can ask them, and you can ping me there.
Okay.
Okay, friends. Anything else? Shall we wind up this class?
Yes, sir.
The course is very affordable. I recommend you to subscribe to this. Okay. So what some people are what they are doing is that they are telling 45 days. They are worrying about this duration. 45 days very bad for me also, but I have to cover the topics, right? That is, yeah.
Hello, sir.
Yeah.
I was today joined a little late due to my office. Office was working. I was working today. So this recording is available anywhere?
Yes, they will mail this to you. Please check the mail. Most probably tomorrow or today they will mail this to you saying that this is the demo. If you want to join, you can join to the next class, and they will be follow up to get the payment done.
Okay.
You will be
because if today I didn't watch today's video, then tomorrow it will be difficult.
Yeah, that will be difficult for you. And they have pinged these details, this admin details in the DURGASOFT in this chat box. You can contact their numbers in case if you don't get the link. But as far as I know, so they will be sending the link every day. Okay. They will be requesting you to, let's say today, the confirmation. They will be sending us the mail. See, today also I got. So like that, today it's a morning community demo class. I got that. So if I click on this, no. So here this is in YouTube, they have uploaded that. So they will be uploading the same thing. You will be getting the same mail. Okay, don't worry about that.
Okay, it will be uploaded on YouTube.
Yeah, it will be uploaded on YouTube, but I don't know whether it will be listed on YouTube or not. But for sure, you will be getting the link through your mail. If not, you can please contact that numbers that they have given.
Okay. The payment number, Google Pay number, this is the same one.
This is unlisted. I think that is not available for the public. You will be getting that through this mail. I think it uploaded at 4:30. It was uploaded. What you are asking?
I was saying one message you had dropped regarding the payment terms and the details. So that is the same number to contact.
Yeah, that is
for
the number.
video.
Yeah, that is being done by the admins only.
Okay, okay, fine.
Okay.
So I will contact if I didn't receive anything for the video part.
Okay.
Okay, thank you.
Thank you, friends. Bye.
Bye bye. Thank you.